Okay, we're going to go over the lesson 3 and 4 worksheet, but before we begin, I just wanted to remind you of how the course syllabus is set up. And so if you actually go to the syllabus, then it's going to tell you that lesson 3 comes out of David Ballard's Algebra 1 Unit 4-5, which means you could go to the videos at math.prairieland.net and you could watch that lesson 4-5. You could watch the homework over 4-5. So if you need more instruction, you can turn there in the book, or you can go to the videos and watch it. Now, this says that you have homework Algebra 1, page 98 to 100. That means you're going to do that on notebook paper and turn it in. That's a part of your homework assignment. And then we're going to learn to graph linear inequalities, and that tells you that if you want to watch the lesson, then you would watch David Ballard's Algebra 1 video, Lesson 5.1 and Lesson 5.4, and then you're actually going to do out of the book homework from the Algebra 1 book, page 128 to 129. So it tells you where to go to watch the videos or where to find the lesson, but it also tells you what homework you're going to have due. And besides doing these two homeworks out of the Algebra 1 textbook, you're going to do the homework practice sheet, which that's what I'm fixing to videotape that we're going to be doing together, and then you'll turn those in on the day of that test. Understand what we're doing. So you know where to look in the book, you know what videos you could look up, you know which homework you're supposed to do, and then we're actually going to do the practices together. Okay? So here we go to that practice, and we'll continue the video. I just wanted you to see that. And so I need to find that. Give me just a second. It's an Adobe scan. I went to the wrong file. I need Pre-Calculus Teacher Resource Book. So we're going to teach Lesson 3, and then we'll just go ahead and teach Lesson 4 and just do this together. It may take 1 or 2 recordings. It says supply the information asked for in the below situations. Now, you're on page 97 in your textbooks, my students, or 97A actually. And on 97A, it lets you know that slope-intercept form of a line is what? Y equal, slope-intercept form is what? Y equal mx plus b. So we learned that slope-intercept form is y equal mx plus b. Now, M is a French word. It stands for a French word like montagne. I didn't say it right. Montagne, which is mountain. So the M actually is for mountain. So it is the mountain slope, if you will. And B is for beginning. And the beginning is the y-intercept, right? So if the equation is y equal 2/3 x plus 4, then what is the slope? The 2/3. And the y-intercept is what's added on, or the beginning, which is 4. From a word problem, we would have put 4 plus 2/3 x, because the 4 is what you began with. It would be more proper to put it first. Now, on page 97A, it says to build a table, we start with x because it is the domain or the independent variable. We solve for y because it is the range or the dependent variable. What goes in the middle is what it says y is equal to, and my equation says that y is equal to 2/3 x plus 4. Understand that? Now we're still quoting page 97A. And then it says, if the slope is a fraction, then you choose multiples of the denominator for x. Now we want some negatives, we want 0, and we want some positives. Multiples of 3 are like 3 and 6. So we're going to use -6, -3, 0, 3, 6. If the slope is a fraction, we use multiples of the denominator for x so that we don't get crazy numbers. Okay? So then we plug in for x, right? So we're going to have 2/3 times the x of -6 plus 4. 2/3 times the x of negative 3 plus 4, 2/3 times the x of 0 plus 4, 2/3 times the x of 3 plus 4, 2/3 times the x of 6 plus 4. So we plug in all of those x's. We solve using the order of operations, sign rules, fraction rules, or whatever other rules apply. 3 goes into negative 6, negative 2. 2 times negative 2 is negative 4, and negative 4 plus 4 is 0. 3 goes into negative 3, negative 1. 2 times negative 1 is negative 2. Negative 2 plus 4 is positive 2. Anything times 0 is 0, plus 4 is 4. 3 goes into 3 once, so we're going to have 2 plus 4 is 6. 3 goes into 6 twice. 2 times 2 is 4, plus 4 is 8. So we created ordered pairs, right? When x is this, then y is that. And we know that we could have called the y f of x. Y is a function of x using function terminology that we just finished. We could plot the points when x is negative 6, y 0. And we know that that would be from the origin here to the left 6, 1, 2, 3, 4, 5, 6, up or down 0. So we could plot that point. We could plot the other point, negative 3, 2, to the left 3 and up 2. And we could draw our line by plotting those points, right? It's always hard to aim. Okay, and we draw our line. Now, we also know that we could have drawn the line by using the slope and y-intercept, right? So let's do that. The graph begins at y is 4. 1, 2, 3, 4. That's that. There's your y-intercept, right? And there, your slope of 2 over 3, slope is change in over change in. And when y is positive, you go, so that means up 2. And when x is positive, you go, and so that's right 3, so up 2, right 3. So from the y-intercept, we could have gone up 2, right 3, made a dot, up 2, right 3, made a dot, and we could have graphed the line using the slope and y-intercept rather than using the points that we got from the table. We need to know how to build a table because sometimes what we graph is not straight. We may have parabolas and hyperbolas and ellipses and circles and all kinds of other crazy things, right? Any questions on number 1? Ready to get? All right. Number 2. Whoops, that went way too far. Sorry about that. Okay, let me get back to the right thing. Wanted to make sure I wasn't jumping to the test or something. Number 2. Now, this is memory work. It's on page 114. Nah, that's wrong. Yeah, I know. Okay, this is on page 104 at the top right. It talks about the horizontal and vertical. So let's see if we can get that. An equation with y only is a horizontal line. See that on the top right of page 104? The slope is 0, and the y-intercept is whatever that number is, right? If it's an x only, it's a what kind of line? Vertical. The slope is, and for y-intercept we put none because it doesn't have one. It's parallel to the y-axis. So you need to do that memory work and recall that from Algebra 1 and Algebra 2 and all of that, okay? So this is an x only, this is a y only, therefore it is a horizontal line. The slope of every single horizontal line is 0. The y-intercept of a horizontal line will be whatever that constant y value was. Okay? Any questions on that? Now, turn in your books to page 96 at the bottom, example 7 and 8. Page 96 at the bottom, 7 and 8. Notice what it says in the oval. It says, we do not make a middle section in our table because y is not dependent on x. Y is constantly something, or x is constantly something. If it's an x only or y only, we're saying there's a constant x or there's a constant y. So when we build our table of x, y values, we do not create a middle section because y is not dependent on x. Y is constantly 5. You can make as many as you want. And x is whatever. So we could just say, well, -2, -1, 0, 1, 2. So an equation with y only is the equation of a horizontal line. The slope of all horizontal lines is 0, and the y-intercept is going to be that constant y value. When you build a table, you do not need a middle section because y is not dependent on x. Y is constantly that number 5, you see. Now, when we graph this, we would find our origin. But we would go to where y is 5, which is up 1, 2, 3, 4, 5 from the origin, and we would draw a horizontal line. Any questions on number 2? If it was x only, it would be vertical. The slope would be undefined. And for y-intercept, we would put none because it wouldn't have one. It would be parallel to the y-axis. Any questions on the horizontal and vertical things? Okay. Everybody good with number 2? All right, number 3. Let me let that click here get out of the way. Now notice we're back on page 97A now, if you want to turn there in your books, page 97A. Example 11 and 12, see that? Now we're trying to come up with the equation from a table. And this is linear equation stuff, which means we need to find the slope and the y-intercept. We know that slope is what? Slope is r change in over change in x. And the reason we said change in y, change in x is that's how we're going to find it in the table, right? So we're going to look for the change in y and the change in x pattern in our table, and that's our slope. When we go from this point to this point, the change in y is a gain of 6. The change in x is a gain of 2. If we put that change in y6 over its change in x2, it will reduce to 3 over 1 or 3. The next change in y is a gain of 6. Its change in x is a gain of 2. The slope is 6 over 2, which is 3. If we have a constant rate of change, we know that it's linear, and that constant rate of change is my slope. Understand that? The y-intercept by definition is the value of y when x equal 0. And in this particular table, the value of y when x is 0 is -2. So my y-intercept is -2, the value of y when x is 0. We're going to write our equation in the form of y equal mx plus b. So we have y equal, m is our slope, So we'd have a 3x. B is our y-intercept, so a minus 2. So my equation is y equal 3x minus 2. Any questions on how to find the slope and y-intercept and write an equation from the table? To graph, we could use our slope and y-intercept. We could just pick a couple of points. The first point is 0, negative 2, which is to the left or right 0, down 2. The second point is 2, 4, which is to the right 2 and up 4. And then you could just draw a line. Any questions on number 3? Okay. Pretty good so far. We're just reviewing some Algebra 1 graphing. As we get deeper into this, we'll be graphing all kinds of things. Parabolas and hyperbolas and square roots and rationals, and they'll be bouncing all over the place and doing all kinds of stuff. And then we'll get to trigonometry, and we'll graph sine waves and cosine waves and tangent waves. So this is the tiptoeing into the big stuff. Any questions so far? Okay. That moves. We'll move on to number 4. Now this is the same kind of thing, except it doesn't give you the y-intercept, and we're going to show you how to mathematically calculate it because we need that skill. Okay? So we're going to begin here with finding the slope, and we know that to find the slope, we do the change in y over change in x. So we're going to find the change in y pattern and find the change in x pattern. The first change in y is a gain of 8, and its change in x is a gain of 2. So we would have 8 over 2, which is 4. The next change in y is a gain of 8, and the change in x is a gain of 2. So we have an 8 over 2, which is 4. There's a constant rate of change, so we know that it's linear, and that is our slope. Any questions on that? Now, the y-intercept is the value of y when x is 0, but this table doesn't have a 0 in it. The smallest thing we had was a 2. Now, we know that you have the ability to work your table backwards, but we're not going to do it that way because we want you to know how to do it algebraically. The way we learned to do it algebraically in Algebra 1 was this. We said if we want to calculate the y-intercept, then we're going to pick a point and the slope, and we're going to plug those into y equal mx plus b, and we're going to solve for b, which is the y-intercept. So we're just going to pick one of the points. The first one is 211. And the slope, which we've already figured out, is 4. And we're going to plug those in. So we're going to take the y and put it in place of y, 11. Slope and put it in place of slope, 4. Crammed on there means multiply. The x in place of x2 plus b. So we got that? So the only variable left is b, which is the y-intercept, so we can solve for that. Okay? Do what? It went to the x. So, that, yeah, the 2 went to the x. Correct. Now, we're going to do this multiplication, so we're going to have 11 is equal to 8 plus b. Now we're going to get the junk off of b, so we subtract 8, and we get b is equal to 3. So we calculated the y-intercept by using our y equal mx plus b formula. You could have used your point slope formula also, y minus y sub 1 equals slope times x minus x sub 1, and then transformed that into slope intercept form. Okay? So my equation then is going to be y equal slope for x plus y-intercept 3, right? You can graph using the points or the equation. The points go off the grid, so I'm not going to use those. I'm going to use the equation. If I graph using the equation, then I'm going to begin at y is 3. And then I'm going to do my slope from there, which is really a 4 over 1, which means to go up 4 right 1. From the y-intercept up 4 right 1, make a dot, and draw our line. Okay. Any questions on coming up with the equation from a table that did not have the y-intercept included in it? And finding the y-intercept using our y equal mx plus b formula, or you could have used your y minus y sub 1 equals slope times x minus x sub 1 formula, which is the point slope formula. Any questions so far? Okay. Number 5. What we're doing on number 5 is we're taking a graph and we're coming up with the slope y-intercept and equation. Now, you'll find this on page 97B of your textbook, and it actually says to find the slope and y-intercept, you look with your eyes. It really does say that on page 97B. You look with your eyes to find the y-intercept, which is the point where the line crosses the y-axis. Now, my origin was here, so that point, that line actually crossed the y-axis at -2. So we looked with our eyes to find the y-intercept, which is the point where the line crosses the y-axis. And the slope, which is the rise over run from one point to another. So we're going to find our rise over run. So we say, well, how do we go from this point to this point? We would go up 1, 2, 3, 4, up 4. And to the right, whoops, 1, 2, y'all help me there, 3, how many is it? 5, 4, 5. I couldn't see the grid there very well. Whoops. So to go from one point to the other, we had to go up 4, right 5. Is up positive or negative for y? Up is positive, so it's a positive 4. To the right is positive for x, so it's a positive 4 over positive 5. So my slope is 4/5. And we know that lines with positive slopes lean to the right, and lines with negative slopes lean to the left. So now I can write my equation, y equal slope, 4/5, x, y-intercept, -2. Any questions on number 5? We wrote the equation of a line from the graph of the line. To do that, we looked with our eyes to find the y-intercept and the slope. Any questions so far? Okay. Number 6. Now we're moving to linear inequalities, which is way over in chapter 5. So, graphing linear inequalities is page 126, chapter 5. Okay. Now, the slope is still the coefficient of x 2/3. The y-intercept is still what we began with, or what's at the end, which is a -4, right? What we need to understand is that little inequality symbol. Now, if it has the equal mark, what do? It's solid. If it does not have the equal to mark, it is dotted. So we have to know when it's solid and when it's dotted. If it has the equal mark, it is solid. If it does not have the equal mark, it is dotted. Now, the other thing is, do you shade up, down, left, or right? Now, how do you know when to shade up? When y is bigger, because y is bigger, up. How do you know when to shade down? When it says y is smaller, because y gets smaller, down. How do you know when to shade to the right? If it says x is bigger, you shade to the right, because that's where x gets bigger. If it says x is smaller, you shade to the left, because that's where x gets smaller. Now, it's only going to say x is bigger or x is smaller if it's a what kind of a line? A vertical line, an x only, you see. Okay, so when we graph, we're going to begin at y is negative 4. Let me get my origin in here. There's my origin. We're going to begin at y is negative 1, 2, 3, 4. My slope of 2/3 means to go up to right 3. So I'm going to go up to right 3, make a dot. But I can't get hurry because I don't know if it's solid or dotted yet, right? Don't zip it through there. You may have to erase chunks out of it. Now, my inequality symbol does not have the equal mark, which tells me that the line is dotted. It does not have the equal mark, therefore it's dotted. So I need a dotted line going through those points. I'll draw the best I can here. Okay. And then I got to deal with the shade. Now, it says y is bigger. Which direction on the y get bigger? Up. So I shade from the line up. Any questions on number 6? So all we've added with the inequalities is when is it solid, when is it dotted, and which way do you shade, right? Any questions there? Okay. Number 7. Number 7 is a what kind of a line? It's a y only, so it is horizontal. It is solid, you were right. It's going to be a solid one, but it's going to be a solid horizontal one. What is the slope of every single horizontal line? 0. What is the y-intercept of a horizontal line? Whatever that constant y number is, negative 4. Slope is always 0 on a horizontal line. The y-intercept is the constant y value. On a vertical line, what's the slope? Undefined. And what do we put for y-intercept on a vertical line? None, because it doesn't have one. It's parallel to the y-axis. So we have a horizontal line through y is negative 4, and it is solid because of the equal mark, right? So we're going to find our origin. We're going to go to where y is negative 1, 2, 3, 4. And we're going to make a solid because of the equal mark horizontal line. Understand that? Then we got to figure out how to shade. It says y is bigger. And we know that y gets bigger which way? Up. And so we're going to shade from the line up. Any questions on number 7? good. All right, number 8. Now, what we're dealing with here is systems of linear inequalities. And what we're going to do is graph and shade and darken the overlapping shade, right? And to be a solution, it must lie within the overlapping shaded region and not be on a dotted line, right? It must lie within the overlapping shaded region and not be on a dotted line. So we're going to graph them both. What is the slope of the first one? We'll do it in green. It's the 2/3, the coefficient of x. What is the y-intercept? The 3. Now on line, it shows you over there to the right, solid or dotted. Is the line going to be solid or dotted? Dotted because it didn't have an equal mark like that under it. That was not there. Therefore, it is dotted. It says y is bigger, so which way do we shade? Up. Okay? Let's go ahead and do that one. The y-intercept is 3. We're going to go up to right 3. It's going to be a dotted line. And we're going to shade up. Understand that? What is the slope of the second one? Negative 1/3. The y-intercept is the line solid or dotted? It's got the equal mark, so it is solid. It says y is smaller. Which direction does y get smaller? Down, so we shade down. Understand that? I understand the solid, dotted, and the shade up and down. Okay? So we'll graph that one on top of the other one. We're going to begin at 9. There's 3, 4, 5, 6, 7, 8, 9. Now, your slope of negative 1/3 means to go down because y is negative when you go down, correct? Down 1 and right 3. So from the y-intercept, down 1, right 3. Had the equal mark, solid line. Y gets smaller down, shade down. The solution to a system of linear inequalities is any point xy that lies within the overlapping shaded region. But it's, it wasn't catching up with me. I got lost. But it's not on a dotted line, right? So the overlapping shade is the solution. It can be in the red, also on the blue solid line that hits the red, but not on the green dotted line that hits the red. It cannot be on a dotted line. Okay? Any questions on that? So, just for example, is this point right here a solution? Yes. Solid line touching the shade. Is this a solution? Yes, in the shade. Is this a solution? No, because it's on a dotted line, even though it hits the shade. What about this little intersecting point? No, because it is on a solid line that hits the shade, but it's also on the dotted line that hits the shade, so that excludes that point because it's on a dotted line. No solution can be on a dotted line. Any questions on what are and are not solutions to systems of linear inequalities? That was actually lesson 3 and 4. And so what you can do now is the homework that was associated with those in your syllabus. Okay? Appreciate your attention.